Hello, welcome back to our second in series of our webinar on the topic Templated Approach to Infrastructure Management and Automation. Today's speakers, as before, are Sridhar and Altaf. This is Sridhar. I am a Senior Software Engineering Consultant, and Altaf is a DevOps Solution Architect. We both work for a company named Aspire Systems. And before we get into the actual content of the webinar today, let's quickly see what Aspire does. Aspire does a lot of product engineering and software engineering. So our core strength is more towards product engineering, releasing MVPs, helping speed up development and all of that. We also specialize in areas like digital services, testing, DevOps, and infrastructure and application support. We are a certified partner for Microsoft Azure and Amazon AWS. We are also CMMI Level 3 certified and ISO 9001 2008 and ISO 27001 2013 certified. We have our international headquarters in Singapore with presence across US, UK, Benelux, Middle East, and multiple locations in India. We are also recognized 8 consecutive times as the best place to work for by the GPW Institute. And as you can see, we have a long list of accolades to our name. So having talked about Aspire, the company that we work for, let's quickly move on to the presentation today. And before that, just as instructions for participants, if there are questions, please write to them. We'll get to those questions at the end of the session or end of our presentation. We'll take them one by one in the order of the actual questions. So the agenda today, as you can see, is a quick recap of what a templated approach is. So during our last webinar session, we talked about a templated approach to come up with a DevOps solution. We'll have a quick overview of that, and once we're done with that, we'll move to today's topic, which is infrastructure, automation, and management. So moving to our recap, during the last webinar session, we talked about 4 different dimensions of DevOps. The dimensions, just to remind us of what we are actually trying to do, are infrastructure management and automation, which is our topic today, release management and continuous integration, continuous testing, orchestration, monitoring, and the feedback loop. So these 4 dimensions are designed in a way that they are mutually exclusive. Work can be done in parallel in each of these dimensions without affecting each other, and they can always be linked together. Things can be worked clubbing these dimensions, but the core pillars or rather the core silos of DevOps are these. Again, these are derived from our experience, from our experience working with a lot of our customers. There can be debatable silos. I think continuous testing has been, there have been a lot of questions around continuous testing being one of the pillars, but I think it does really fit in there. It does really sit well within dimensions, because testing is also a part of your DevOps pipeline, and that is why 4 dimensions here are what we've observed, we've known to be true. And along with the dimensions, we also looked at what we call parameters. By parameters, we mean things that affect your decision in each of these dimensions. So again, to recap, the 5 dimensions are distribution, which talks about how your teams are distributed, how your deployments are distributed, and everything else. The next parameter is technology, which simply talks about the technology stack that you're going to use in your product. The scale and load, which is again, as the name suggests, the scale of your application, the load that it faces, future and current. The fourth dimension is environment and security, and I think the name says it all. And the fifth parameter is release. On the release angle, we talk about where it is released, how it is released, and what frequency and all that. So these 5 parameters put together can help you decide what constitutes a DevOps plan. So this is typically the starting of our templated approach. And what we are attempting to do with this whole approach is to derive a plan that is something like this. Something that tries to get details on tools, processes, and control mechanisms for each of the dimensions based on the parameters that we've listed out. So that's a quick recap of what happened in the previous webinar. Now let's quickly jump on to infrastructure management and automation. So today's topic is to see how we derive a template for infrastructure management and automation. So to start with, let's first look at all the individual components in infrastructure management. As you can see, the first component is configuration management. Clearly distinct from configuration provisioning. Configuration management is more about maintaining configurations, maintaining code and scripts that are required to eventually provision your application in a hardware, in a cloud or a hardware environment. So this is more of more related to tools like Chef and Puppet and so on. Right. The next component is config provisioning as such, which basically deals with your hardware, deploying your hardware, scaling them, monitoring them, scaling down or up, whatever. Right. And the third component is the infrastructure orchestration, which, as the name suggests, is a process where the infrastructure as such is automated, automatically managed, orchestrated in the sense the configuration management and the provisioning components work together to come up with a live application and manage it. And the infrastructure orchestration component helps that link. The fourth, and as you can see on the picture, the fourth component is the biggest component, log management, monitoring, and custom scripts. It might sound trivial, but these are primarily or mostly the case where we have a lot of work. And the name is straightforward. I don't need further explanation of what it does or what the component is all about. Let's jump on to look at the tools that we use for infrastructure automation. So one of our goals in the templated approach is to identify tools for a given use case, right? So before that, we have to look at all the tools that are available. So listed here are some of the tools that we use for infrastructure automation. And again, they are boxed into their appropriate components. I'm not going to read them all out to you. I'll leave it to you to go through it. If you need, you can come back to us. And I'm pretty sure there are more tools out there, and I'm pretty sure there will be more coming in the near future. So there's no point in looking at each of them, but what Aspire as such is doing is we are actively maintaining a knowledge base of each of this tool and also maintaining a set of rules around each of these tools. So what Aspire has is a proprietary set of knowledge that is being built into a tool that can eventually be used for our clients. So let's quickly skip this slide and go to the next slide. So the first approach that we're going to do today is a simple elimination approach where we go through every tool, we go through every process, we go through every control mechanism. We filter or narrow them down to a few that can be used based on criteria that are more suitable to your condition. And based on the final selection or the remaining tools, we decide processes and the control mechanisms, and we try to arrive at a plan as such for infrastructure automation. Again, this approach can be applied for other dimensions as well, but the actual criteria for elimination would change in the other parameters or other dimensions. So in the first case, to determine appropriate tools for your condition, there are certain constraints that every tool has, and those will be a first condition to eliminate them. So looking at them, every tool has a technology-based constraint. So like say some tools would work better with C# code or Java code or Python code, whatever it is, right? So tools always have a technology constraint. They have licensing constraints. The community support plays an important role. The distribution capabilities of the tool, and dependence of other software or hardware, which is sort of a tie-up. It also deals with, I mean, we also have to look at the level of loose coupling, and the dependence is sort of allied to that. So we would want things that are not too dependent on hardware or software or any sort of tie-up to a particular thing, right? And we also have to look at security concerns and the release frequency that the tool can support. So these are the tool constraints, and applying all of these constraints, we can possibly arrive at a finite set of tools that are applicable. And once we have that finite set, we can use the finalized list of tools to choose our processes. So our processes, apart from whatever the tools impose, processes have their own constraints with respect to the chosen process. This is more of a personal, a company's decision to say. Processes are mostly defined internally. They would want a certain level of control and all that. So processes can be embedded directly into the tool set. So it all depends on what processes you already currently have, and adding to that whatever tools that are chosen for the particular job. That will give you a finite set of processes. To choose a set of control mechanisms, the only thing that adds on to whatever constraints we've seen before is the org structure as such, or the team structure, to say how the control of releases go, to say how or who approves what and all that, right? So this process obviously in most cases would come out with more than one tool. It mostly is never one single tool for everything. Those are very rare cases, and if it does, I think we may be doing something wrong, in which case we may have to redo the whole exercise, giving in new parameters and things. So typically, a complete solution is always derived with multiple tools, and all of them working together with the defined processes and control mechanisms. So having talked about the approach, the plan, let's quickly go into a few exercises where we take a few examples, try to apply the templated approach, and see how it works out, see what the plan it throws. And I'll let Altaf take over. He's a senior DevOps consultant. He can take you through the exercise.
Sure. Thank you, Sridhar. Hello, everyone. I'm Altaf. And moving on to use case. Some of you might be knowing that whatever the list of use cases we have here, these are the one which we went through in our last webinar. So we want to take the same scenario again so that we will have a more clarity, like how the templated approach did help us in narrow down the list of finite tools so that it could help us in giving a more clear picture in a real-time scenario. So moving on to the use cases, we have 4 different use cases here. I mean, every use cases are different from each other. I mean, if you look at the first one, it has a very minimal feature kind of a development cycle. Let's say the customer wants to build an in-house product which has been developed using a .NET stack, and the complete development happens and the product being served to internal employees. So about the second scenario is something which is similar to the previous one, but then it is kind of a hosted solution and been out to a public, and again it has been developed using a LAMP stack. The third one is a little more complex than the previous one. This is something kind of a product development wherein there are 2 set of development happens. One is during the initial phase where the product development happens, and the second stage where the company let their customer to integrate the suite, more related to a integration side, wherein they have a second set of development cycle. And the fourth one would be a Saas model, wherein let's say a company want to develop a product in a microservice architecture or like a container-based approach, and being maintained, I mean, being a Saas model, I mean, everything being maintained within a company, and they have the complete control. So it is more like a lengthy development cycle, I would say. So we have 4 different scenarios here. So considering that the time constraint and other things, probably we wanted to take 2 scenarios and walk you through with a templated approach to identify the right tool set on how it could help us in narrow down the list from the huge set of tools available in the market. So that way we will have we will end up seeing a very minimal or kind of a few number of tools which we could probably pick the right ones based on the business need. So let's move on to the product development. So we'll choose 2 scenarios, product development and the Saas model here. So to start with the product development, before going into a product development scenario, we just wanted to show you the few list of tools available in the market in each category of infra automations. And I'm sure like there are more other tools available, but then we wanted to take the top 10 kind of, I mean, even in fact we have more than that, but just wanted to give the selective list of tools, and then to start with applying a templated approach. So let's move on to the exercise product development. So having said, like we have 5 different parameters that we get from the customers. I mean, this is something to understand and applying a templated approach from the business requirement point of view. So we'll start with the first parameter, distribution, to see like what the product requirement from the distribution side. It has been served in a multiple geographic location, and they have 7 different teams and end users in the multiple geographics. So with that, whatever the number of tools we have, it doesn't change much, since it doesn't relate to that particular items at the moment. And let's see what happens with other parameters. So for the technology, we get an input like the the development happens on a Java stack, and the deployment model is an Infra as a service. And likewise, you can see that kind of a like filter being applied with the previous list. I mean, just to go back and give you what happens exactly. Earlier, like we have around 11 entries in the config management and 18 in config provisioning, 11 in the orchestration, and around 15 plus in the monitoring side. Now, if you look at it, hardly like we have half number of the tools in each, even there are, more and less. But then let me tell you what happens exactly and what kind of a templated approach and concept we applied. So in this scenario, if you look at it by seeing the input on the technology, which is a Java stack. So earlier, like we used to have the config management side, there are tools which are meant for a .NET development, like a Microsoft SCCM, which has a Microsoft dependency, and Foreman. Foreman is more kind of a SysOps related tools, and I'm sure like it could be utilized on the config management. But then, considering that we have similar feature tools with a more community support and more kind of a platform and the open source side of support we have. So we are trying to filter and eliminate as much as we could, but it doesn't mean like we are trying to miss something intentionally. And also like we are trying to apply something on the configuration provisioning side. If you look at it earlier, like we used to have the container related services and software. So those are the ones which we eliminated because the deployment model stating it is a infrastructure as a code and it doesn't require a container to be considered here. And likewise, we applied a templated questions. I mean, when I say template, it's nothing, it's more like a certain list of questions to justify whether the tool is capable of supporting the right platform aligned with the business need, and more in terms of the community and license model. Also, at most concerned about the cost management and other things. Also, if you look at the other columns wherein we have the monitoring and log management, you could see that we have filtered a few, like the log management tools and the monitoring tools as well. So let's move on to the next input, which is a scale and load. So it states that it needs 10,000 concurrent users. I mean, the application's development is expected to serve 10,000 concurrent users. With that answer, I could see that whatever the tools we have already filtered has a capability to do the same thing, and it doesn't have a much limitation in terms of supporting. And then moving on to environments and security. Here it is interesting. I mean, we get environment details. I mean, the development trying to happens in the delivery on the AWS side, wherein we get a more like a filtered number of tools. Since the earlier one we had, we were in kind of like we were not sure about the platform, whether it is a private or public. When I say public, again, there are multiple providers. So when we get to know about the AWS input, we are trying to apply more conditions on top of the earlier list, and then we get more like a finite list of tools. But still, we have alternate options given, considering that we don't want to go with a more dependency on the AWS alone. For example, if you look at a configuration management side, though we have the OpsWork, which is capable of handling the config management, but still we also have a similar options available in the open source side, which is a Puppet and the Salt. And also on the configuration provisioning, the CloudFormation is the right tool set to go with. as a kind of a best practice if you consider about AWS, but still we kept another alternate option for the Terraform, so that in case of any other such requirements to be handled other than the AWS, Terraform is the right tool set to go with. Similarly, on the orchestration side, it depends on the business need as well. Let's say like if someone wants to go through an approval mechanism and more like a workflow management to do a hybrid cloud management kind of things, probably like they could very well pick the ServiceNow to do the orchestration. And similarly on the monitoring, log and management, we kept all the possible options like a Nagios, which is the older and stable version for the monitoring, and the CloudWatch, which is inbuilt options available within AWS, and you will get all what you want. And similarly on the Splunk and Logstash is for the log management. The same thing remained there for the release as well. So now, here is an interesting slide where we have the finite list of tools. This is something we end up seeing after applying the templated approach, but then there are a few more portions to be considered. One is the process and control mechanism. Now that we have all the filtered tools, and based on the business requirement and the need, we need to define and we need to create the process kind of a workflow to decide how you want the tools to react. For example, where and when the infra need to be auto-scaled and kind of a failover as well. Similarly, the control mechanism is something which is which you want to place a checkpoint, kind of a gatekeeper, and define the relevant people or kind of a team to do a approval process kind of things. So altogether, it gives you a kind of a finite approach and will help you from all the aspects. For example, in the same scenario, it is not only mean for CI/CD, I mean end-to-end pipeline. From the customer point of view, they may have a requirement to do continuous delivery, wherein they want to do automations on the infra as a code point of view, or they may even want to do ITSM side, wherein they want to apply kind of a workflow catalog mechanism, or maybe kind of a continuous deployment model. So all the aspects, if you look at it, you can select the relevant tools, and probably you could achieve in the better way by applying the right process and creating a control mechanism. So let me go through another scenario, which is quite different from the previous one, which is a Saas model. Having said, let's say a customer wants to go with a microservice architecture in a container-based model, which is happening on the cloud. So let's see what happens by applying the template here. So looking at the distribution, again, we don't see a change in the number of tools, and the technology, it returns that the development happens on the .NET stack, and the deployment model will be a container model. So again, if you look at the config management, you see a sudden decrease in the number of tools, and it is having only one option, which is a packer. I mean, we need to understand something here in terms of the containerization. Containerization itself, it is a config management in another meaning. I mean, configuration management is something which takes care of configuration changes across the systems or kind of like cloud environment, wherever the machine runs on. But then when it comes to a container, if you try to make some changes within the container itself, it is not advisable, as containers doesn't have the long life unless you have something like a persistent volume. So in that aspect, if you look at it, we don't deal much with the configuration management inside container. So whatever it happens within the container being handled as an inbuilt feature. But then the Packer is something which takes place and plays a major role in doing a building image and kind of like repository handling and other stuff. So we consider that Packer might help you in doing something relevant to a configuration management. So looking at the configuration provisioning, again, since it is a container model, so we could see that we are applying a filter and we could see the only relevant tools which are capable of handling containers. Likewise, we have the change in orchestration as well. If you look at it, the Kubernetes, Docker Swarm, Rancher, Jenkins, ServiceNow, and Cloudify. And likewise, you will also see a change in the monitoring and log management. If you look at it from the log management side, we have suggested Logly and paper trails. And the things to be noted here in terms of the log management when it comes to a container log management is something different from the normal use case, wherein the log, for example, let's say you have an application running inside the container, the same scenario wherein we have a microservice architecture. So it is not advised to do a normal log management in this scenario. We need some sort of a centralized management tool. So from that aspect, the Logly or a paper trail play a major role. Hence, we are applying a filter, and we could see that these are something relevant to this particular scenario. Let's move on to the next one, which is a scale and load. Again, with that, we don't see much change in the tool, as whatever we have given here are capable of handling the scale and load. And environments and security is something which gives a more clarity about the requirement, and it states that the environment is Azure environment. Hence, we see the reduce in numbers, but again, we could see that some alternative option as well, like Terraform, which is capable of doing the container provisioning across the cloud, more like a hybrid cloud or on-premise model. And we have a similar options available within Azure, which is ARM and Kubernetes, because the Azure Container Service itself has an inbuilt options. I mean, there are 3 different options available: Core OS and Kubernetes, and then the Docker Swarm. So it depends on the business need. Probably they could select the right ones. Similarly, from the infrastructure orchestrations, we have given a Cloudify. Since the Cloudify has a plugins available to handle the container orchestration over Azure Cloud. And likewise, we have given the Jenkins, ServiceNow, Docker Swarm, and Kubernetes. And then you will see there are some changes in the monitoring aspect, because we don't want to go with the 10 number of tools, though there are the valid tools available. But considering that this is a container based, so we wanted to go something relevant to and make work easy in terms of integration and implementing the plugins and etc. So looking at the release, I mean, adding to the release point of view, again, these are all the finite list of tools. So let's see what happens now. So if you look at it, this particular microservice architecture scenario, we end up seeing quite a few number of tools on each category. But again, it depends. For example, let's say you have something to deal with a Microsoft based development, wherein you have something to deal with a SQL Server, for example, the replication part. This is something can be handled in a better way with the Azure Container Service through a Kubernetes, which may not be easy going through a Docker Swarm. So it depends on the business need and the way they want to achieve. They can select the right tool set. Whatever the templated approach that we are talking about, it could only help us in identify or narrow down from the huge list, but then we may not be able to predict on the exact requirement unless the process and the control mechanism and the detailed requirement been decided. So with this scenario, the process and control mechanism are similar to the previous one, wherein we define our own process with the conditions and the way that we want the tools to react. More like what kind of replications that you want, what level of the auto scale you want that to be in place, and control mechanism will be like who deals with what. For example, the RelOps people deals with the release management, and the SysOps people owns the Kubernetes part, etc. And this is something I'm sure, like with the two different scenario, we could imagine, or we could probably get an idea about how or what kind of the templated approach we could apply with our own scenario, because there are multiple scenarios in the real world. I mean, whatever we have explained are a few. And also, like when I say templated approach, again, just wanted to repeat. I mean, there are a certain list of questions to justify and narrow down the list. This could only help us in identifying the tools, but then the way that you want to implement and integrate, it depends on the purely from the business requirement point of view. Probably I'll hand over to Sridhar to provide a better conclusion on this part.
Sure. Thanks, Altaf. So what we've seen today is more of an example of how we apply the templated approach, how we apply elimination as one of our processes to choose a finite list of tools that can help us. Again, these are just examples. We can give more examples, but in the interest of time, we restricted ourselves to two. But again, we also have a proprietary list of such rules that is a collection of, more of a rule set that applies to a given set of inputs. We've been developing this rule set and have also been trying it out with a few of our customers. So far it has been a little successful. We've been able to suggest the right things. And we've also set a stage for the selection process, starting with the elimination approach. We would be coming up with other methods to choose processes, but a good start is always an elimination process. So thanks for attending. If there are questions, we'll take them now. So the first question, as seen, is has Aspire implemented this approach for any of our customers? Not yet, in the sense we've not applied the approach per se, but we've used it as a validation tool. We've been able to use the tool to predict the DevOps requirement, and we've been able to validate it with the customer and make sure that he is comfortable, he or she or whoever the client is comfortable with the tool set that is identified. And again, the final list, the final template is always taken through a process where it is again validated by an architect or a consultant. So it has been quite successful so far. That's as much as I can say for now. And the second question is, what are the business benefits of using this approach? And as I was saying, the primary benefit as such is to validate our own thoughts of how something should be. Right? On the DevOps world, there are multiple choices. There are, in fact, a wide variety of choices that makes it difficult for someone to come up with a perfect plan. So it is always a compromise somewhere or a combination of certain things. And it is always quite nice to hear a validation of what we think. And I think this approach gives that first step of validation, gives a confidence that the solution is in fact right. The second benefit is, of course, it reduces or saves time if you're trying to, if you start believing in it and start using it. I think it saves a lot of time. It comes up with the finite set immediately, and then you can start working around it. So time is money, and I'm guessing it saves money as well. So I think that those are the questions so far. I'm not sure if we should wait for any more questions, but you can always get back to us if needed. The email should be here. If you can mail your questions to mariajosephine@aspiresys.com. We'll get back to you. Again, thanks for listening in.